We will now learn about ancient and modern calendars, including an ancient calendar still in use today. We must learn about calendars because we need to convert dates of ancient calendars into our modern calendar dates so we can understand the prophecies and astronomical evidence God has given us for the return of the prophet Elijah. The first recorded use of a calendar in Scripture is the Hebrew calendar specified by the law of Moses, which God used to tell the children of Israel when to perform different religious observances or events. Other religions also use their own calendars for similar purposes. A second reason for a calendar is to reliably identify when certain astronomical events occur. For instance, the annual spring and fall equinoxes when the length of day and night are equal, and the summer and winter solstices when the northern hemisphere's day is longest and shortest, respectively. A third reason is for people to reliably identify past dates and predict future dates for family, commerce, government, and space travel purposes. To do such requires an accurate calendar so repeating astronomical events occur on the same date each year. We will discuss the following calendars with their characteristics and their advantages and disadvantages. The Hebrew calendar, called the Jewish calendar today, was given by God to the children of Israel as part of the law of Moses in the book of Exodus in the Old Testament. This calendar established a 7-day week, with the seventh day being the special Sabbath day reserved for worshiping God. The first day of the Hebrew or Jewish week is our modern Sunday, and the seventh day of the week is our modern Saturday. Many modern calendars show a week with Sunday as the first day of the week and Saturday as the seventh day of the week, which parallels the Jewish week definition. The calendars of many Christian countries, especially in Europe, show the week starting on Monday and ending on Sunday, the Christian Sabbath, so it is the seventh day of the week. The Hebrew calendar has no actual names for the days of the week, other than the seventh day being named the Sabbath. Jewish day of week naming refers to the first 6 days of the week as day 1, day 2, etc. to day 6. However, day 6 has acquired an alternate name of day of preparation, which refers to the day when Jews must prepare everything needed for the Sabbath day, since they cannot travel, shop, or cook on the Sabbath day. The law of Moses also specified what constituted a day. A day starts at sunset, which today is about 6 p.m. for a 12-hour clock and hour 18 for a 24-hour clock. A Jewish day has 12 equal periods of nighttime followed by 12 equal periods of daylight, which varied in length based on the length of daytime and nighttime at different times of the year. In modern times, with modern usage, we call these periods hours, and they do not vary in length during the year. Have you wondered why the Jewish day starts at sunset? The record of the creation in the Bible's book of Genesis, chapter 1, verse 5 specifies, "The evening and the morning were the first day." So a Jewish day starts at sunset, which is the start of evening. The graphic displays a modern day on the top half and a Jewish day on the bottom half. The gray color illustrates the 12 periods of nighttime in a Jewish day, and the yellow color the 12 periods of daytime. The New Testament refers to these periods as hours. Note the graphic shows the same gray and yellow hours for our modern day. In our modern calendar, a day starts at midnight and ends at the next midnight, between which we experience a sunrise, noon, and a sunset. A Jewish calendar day starts at sunset and ends at the next sunset, between which the Jews experience midnight, a sunrise, and noon. The Jewish reckoning of time of day uses sunset and sunrise as the names for the first hour of each half day. Succeeding hours are named the first hour, second hour, etc. through the 11th hour, meaning that many hours after the sunset or sunrise hour. You can see this hour numbering along the bottom of the Jewish half of the graphic. In the scriptures, daytime periods are simply specified as, for example, the ninth hour, which is a 12-hour clock's 3 p.m. and a 24-hour clock's hour 15. Nighttime periods can be specified as, for example, the fourth hour, which is a 12-hour clock's 10 p.m. and a 24-hour clock's hour 22. The scriptures often group nighttime hours into a watch, which is a 3-hour block, possibly because cities set out guards to watch over a city during the night and had 4 shifts of guards that each guarded the city during their watch. For example, sunset and the first and second nighttime hours are the first watch, which is 6 p.m. to 9 p.m. The third through fifth nighttime hours comprise the second watch, which is 9 p.m. to midnight. The 6th through 8th hours and the 9th through 11th hours make up the 3rd and 4th watch, respectively. This start of the Jewish day at sunset has the effect of having the first 6 hours of a Jewish day at the end of our modern day, from 6 p.m. to midnight, and the remaining 18 hours of the Jewish day in the first 18 hours of the next modern day, from 12 a.m. midnight to 6 p.m. In other words, a Jewish day overlaps two modern days. With days that start at different times, the Jewish day at sunset and the modern day at midnight, how do we today assign a Jewish date to a date in our modern calendar? Using the graphic as an example, should the 14th of Nisan convert into our modern March 31st because the Jewish day starts in the evening of March 31st at 6 p.m.? Or should the 14th of Nisan convert into our modern April 1st because it has more hours of the Jewish day? For the purposes of commerce and government, modern day usage assigns the Jewish date to the modern date that contains the same noon as the Jewish date, which in the example in the graphic assigns the 14th of Nisan to April 1st. You will see this convention followed later in the presentation when we convert between modern and Jewish calendar dates. The Hebrew or Jewish calendar is a so-called luni-solar calendar that uses both the moon and the sun. Months are determined by the cycle of the moon. A lunar month starts on a new moon, which is when the moon is between the earth and the sun. Since a lunar month is slightly more than 29 and 1/2 days, the Jewish calendar has months that alternate between 30 and 29 days, giving an average month of exactly 29 and 1/2 days. Years are determined by the sun. However, 12 months with 6 30-day months and 6 29-day months yield a year with 354 days, which is 11 and 1/4 days short of the actual solar year. The Jewish calendar's first month is the month of Nisan. A Jewish year must start such that the 15th of Nisan falls on or after the spring equinox, because the scriptures state the Passover celebration must occur in the spring, and the spring equinox is an observable event considered the start of the spring season. With a calendar short by 11 days relative to Earth's year, the 15th of Nisan will occur 11 days earlier each solar year, and therefore most years Passover would not be celebrated in the spring. The Jewish calendar resolves this issue by adding one 30-day leap month to a year, which yields a year with 384 days. So, if the 15th of Nisan the next year will occur before the spring equinox, this year becomes a leap year to force the 15th of Nisan back to on or after the equinox, which means the month of Nisan and a Jewish year usually start in March but can start in April if the previous year is a leap year. This means the Jewish calendar bounces all over the place, with each year starting on a different day or even different month of our modern calendar. Despite the complexities of the Jewish calendar, modern Jews still use it to identify when they must perform and observe the religious events and celebrations dictated by the law of Moses. Complicating the Jewish calendar further, there are 4 rules that can shorten or lengthen the Jewish year by 1 day, resulting in a 353-day or 355-day year respectively. This introduces even more variability into the Jewish year. Since the standard common year was already out of sync with the sun by 11 days each year, this means the Jewish year can be out of sync by 10, 11, or 12 days each year. To handle being out of sync with the sun, the Jewish calendar has 7 leap years every 19 years, which is known as the Metonic cycle. This cycle makes the Jewish calendar align very closely with the sun every 19 years and permits Jewish communities to know the Jewish calendar for future years. The rules combined with the leap month causes a leap year to have 383, 384, or 385 days, which the Metonic cycle handles. As you can imagine, the Jewish calendar really jumps all around relative to our modern calendar. Before the reign of Julius Caesar, the Roman Emperor, the Roman Empire started a new calendar when it had a new emperor. This, of course, played havoc with historic dates and records and prevented the use of future dates. Julius Caesar created a new calendar that gave us our current weekday and month names, with Julius naming July after himself. Caesar based this calendar solely on the sun and ignored the moon for its months. The calendar had 365 days in its common year and added 1 leap day every 4th year for its leap year to handle the fact the solar year is just shy of 365 and 1/4 days. This means the Julian calendar had 100 leap days every 400 years, but unfortunately that made it increasingly out of sync with the sun by 3 days every 400 years, so that the spring equinox occurred earlier and earlier on the calendar over the centuries. In the 6th century, a monk named Dionysius Exiguus of Scythia Minor introduced the abbreviations BC before Christ and AD, Anno Domini in Latin, which means in the year of the Lord in English, to indicate the years before Christ and those after Christ respectively. This changed the numbering of years so they are relative to Christ's birth instead of relative to the start of the Julian calendar. This BC and AD usage meant there was no year 0. That is, the last day of year 1 BC is followed by the first day of year 1 AD. This was very likely done because the numbering system in use at the time was the Roman numeral system, which has no 0 because Romans did not understand the concept of 0, which 6th century Europeans likewise did not. In Western civilizations, such as those in Europe, dates recorded in documents are Julian dates up until 1582 and later, depending on the country. Because astronomical events slowly moved to earlier dates in the Julian calendar by 3 days every 400 years, in October 1582, Pope Gregory XIII introduced the Gregorian calendar to correct this problem. It has the same month names, weekday names, days of months, and BC and AD year numbering as the Julian calendar. The European countries following the Catholic religion quickly adopted this calendar. To switch from using the Julian calendar, which by 1582 was 10 days out of sync with the sun, to using the Gregorian calendar, the Julian calendar date of the 4th of October 1582 was followed the next day by the Gregorian calendar date of the 15th of October 1582, which restored astronomical events back to the same day every year. Unfortunately, the European countries of the Protestant and Anglican faiths and their colonies in the Americas did not trust the Pope and did not adopt the Gregorian calendar until decades and even centuries later. The last country to change to the Gregorian calendar was Turkey in 1928. Like the Julian calendar, the Gregorian calendar is based on the solar year with 365 days in a common year. And like the Julian, the Gregorian has one leap day every 4th year, except, unlike the Julian, there is no leap day on the years evenly divisible by 100, such as the years 1700, 1800, and 1900, unless they are evenly divisible by 400, like 1600 and 2000, which do have a leap day added. This means the Gregorian calendar has 97 leap days and years every 400 years, which handles the fact the solar year is slightly less than 365 and 1/4 days. The Gregorian calendar is quite accurate astronomically and is the modern-day calendar we use today. One other calendar of significant importance for the major events of the life of Jesus Christ is the Nephite calendar started by the Nephite nation in the Americas on the date of his birth, as recounted in the Book of Mormon. Why the Nephite calendar is significant is because the Nephites recorded their calendar date in the Book of Mormon on which Jesus Christ, the Messiah, died in Jerusalem. Without this date, no one would know when Jesus Christ was crucified and died, nor when he was resurrected. And without this Nephite date, you would not be watching this presentation. Like the Julian calendar of the time, the Nephite calendar was likewise based on the solar year and had 365 days. Unfortunately, for astronomical accuracy, it did not have any leap days, which means this calendar was increasingly out of sync with the sun by 97 days every 400 years. The Nephite calendar parallels the Mayan civil calendar adopted about 100 BC in Central America, which likewise had a 365-day year with no leap days. The Hab calendar has 18 20-day months and a 19th month of 5 unlucky days. The first day of each month is numbered as day 0, which the Mayans could do because, unlike the Europeans, they understood the concept of 0 and used it. Note the Mayan Hab calendar does not have years because Mayans used a different calendar, known as the long count calendar, to identify years. In fact, all Mayan records that specify a Hab calendar date always also specify its long count calendar date. Even though we do not know the particulars about the Nephite calendar's number and length of months, for the purpose of this presentation we will assume it used those of the Mayan Hab calendar, so we can show a month name and day of month number. We will use the Nephites' year count for the year number. We can do this because the dates mentioned using this Nephite calendar in the Book of Mormon are always in the first month of such and such year, and so the number and length of months really does not matter. All that really matters is this calendar had a 365-day year with no leap days.